Written by Neil deGrasse Tyson, look up at the night sky, far from city lights. On a clear evening you'll see a faint band of light stretching across the heavens. This is the Milky Way, our galactic home. It's a vast collection of stars, gas, dust and planets, all held together by gravity. We are part of this incredible structure, a tiny part of something much grander than ourselves. Understanding the Milky Way helps us understand our place in the universe. The Milky Way gets its name from its appearance. To the naked eye, it looks like a milky band of light across the sky. Ancient civilizations created myths and legends about this celestial river. We now know this light comes from billions of stars. Their combined light is too faint to see individually, but creates the Milky Way's glow. The darker patches within the band are not empty space. They are huge clouds of dust blocking the light from the stars behind them. The Milky Way is a barred spiral galaxy. Picture a flat disk with a central bulge and you have the basic shape. The bulge, called the galactic center, is a densely packed region of stars. From the bulge, spiral arms wind outwards. Our solar system resides within one of these arms. Surrounding the entire disk is a halo, a spherical region of stars and mysterious dark matter. This halo is much fainter than the disk and contains globular clusters, ancient groups of stars. Stars are the most prominent members of the Milky Way. They are the building blocks of galaxies, lighting up the cosmos with their radiant glow. Each star is a massive, luminous sphere of plasma held together by gravity. The sheer number of stars in the Milky Way is staggering, with estimates suggesting there are over 100 billion stars in our galaxy alone. They come in a variety of sizes, colors, and temperatures. From the smallest red dwarfs to the largest blue supergiants, stars exhibit a wide range of characteristics. Red dwarfs are cooler and less luminous, while blue supergiants are incredibly hot and bright. The color of a star is indicative of its temperature, with blue stars being the hottest and red stars being the coolest. Some stars, like our Sun, exist alone. These solitary stars are known as single stars, and they make up about a third of the stars in the Milky Way. Our Sun, a G-type main sequence star, is a perfect example of a solitary star, providing the necessary light and heat to sustain life on Earth. Others are part of binary systems or star clusters. Binary star systems consist of two stars orbiting a common center of mass, bound together by gravity. Star clusters, on the other hand, are groups of stars that were formed from the same molecular cloud and are gravitationally bound. These clusters can contain hundreds to thousands of stars, all moving together through space. Nebulae, vast clouds of gas and dust, are the birthplaces of stars. These stellar nurseries are regions where new stars are born from the gravitational collapse of gas and dust. The process of star formation is complex and involves the accumulation of material in a protostar, which eventually ignites nuclear fusion in its core. They glow with vibrant colors, illuminated by the light of nearby stars. The colors of a nebula are determined by the types of gases present and the intensity of the radiation from nearby stars. For example, hydrogen gas emits a red glow, while oxygen gas emits a green or blue glow. These stunning displays of color make nebulae some of the most beautiful objects in the night sky. Black holes, regions of space-time where gravity is so strong nothing can escape, lurk in the Milky Way. These enigmatic objects are formed from the remnants of massive stars that have undergone gravitational collapse. Black holes can vary in size, from stellar mass black holes, which are a few times the mass of our Sun, to supermassive black holes, which can be millions or even billions of times more massive. The most massive black hole resides at the galactic center. Known as Sagittarius A, and other black holes continues to be a major focus of astronomical research, offering insights into the fundamental nature of gravity and the evolution of galaxies. Our solar system is located about 2/3 of the way out from the galactic center. We are situated within a minor spiral arm called the Orion Arm. From our vantage point, we have a limited view of the Milky Way's structure. It's like trying to map a forest while standing in the middle of it. However, astronomers have developed various techniques to study the Milky Way. By observing the motions of stars and gas, they can piece together a map of our galaxy. The Milky Way is a giant among galaxies. It is a vast, sprawling collection of stars, planets, gas, and dust, all bound together by gravity. When we look up at the night sky, we are peering into just a small part of this immense structure. It spans about 100,000 light-years in diameter. To put that into perspective, a light year is the distance light travels in 1 year, which is about 6 trillion miles. So the Milky Way is roughly 600 quadrillion miles across. That means it takes light, traveling at 186,000 miles per second, 100,000 years to cross from one end to the other. Imagine a beam of light starting at one edge of the galaxy. It would take longer than the entirety of human civilization to reach the other side. The Milky Way is home to an estimated 100 to 400 billion stars. Each of these stars could potentially have its own system of planets, moons, and other celestial bodies. Our own solar system is just one tiny part of this vast cosmic neighborhood. It's an ancient structure, with an estimated age of 13.6 billion years. This means that the Milky Way has been around for almost as long as the universe itself. Over this immense span of time, it has seen countless stars born, live out their lives, and die. That means the Milky Way formed shortly after the Big Bang, the event that created the universe. The Big Bang occurred about 13.8 billion years ago, and within a few hundred million years, the first stars and galaxies began to form. The Milky Way is one of these early galaxies, and it has grown and evolved over billions of years to become the majestic structure we see today. The Milky Way is a barred spiral galaxy, which means it has a central bar-shaped structure made of stars, with spiral arms extending outward. These spiral arms are regions of active star formation, where new stars are born from clouds of gas and dust. The central region, or galactic bulge, is densely packed with older stars, and is thought to harbor a supermassive black hole at its core. The entire galaxy is in constant motion, rotating around its center. Our solar system, located in one of the spiral arms, takes about 230 million years to complete one orbit around the galactic center. This means that since the time of the dinosaurs, our solar system has only made one full trip around the Milky Way. In the distant future, the Milky Way is expected to collide with the Andromeda Galaxy, our nearest galactic neighbor. This cosmic event, set to occur in about 4 billion years, will result in the merging of the two galaxies, creating a new, larger galaxy. Despite the vast distances between stars, such collisions are relatively common in the universe and play a crucial role in the evolution of galaxies. The Milky Way is not just a collection of stars and planets, it is a dynamic, ever-changing entity that has witnessed the birth and death of countless celestial objects. It is a testament to the grandeur and complexity of the universe, a galaxy of numbers that continues to inspire and amaze us. The Milky Way is just one of billions of galaxies in the observable universe. Galaxies come in various shapes and sizes. Some are spiral galaxies like our own, others are elliptical, irregular, or lenticular. The Milky Way is part of a group of galaxies called the Local Group. Our closest major galactic neighbor is the Andromeda Galaxy, a spiral galaxy even larger than the Milky Way. These two galaxies are on a collision course and will eventually merge in the distant future. Studying the Milky Way provides insights into the formation and evolution of galaxies. The Milky Way, our home galaxy, is a barred spiral galaxy that contains billions of stars, planets, and other celestial objects. It stretches over 100,000 light-years in diameter and is a part of the Local Group of galaxies, which includes Andromeda and the Triangulum Galaxy. By observing the Milky Way, astronomers can trace the history of star formation, the distribution of different types of stars, and the presence of dark matter. These observations help us understand not only our galaxy but also the fundamental processes that govern the universe. By understanding our own galaxy, we gain a deeper understanding of the universe as a whole. The Milky Way serves as a cosmic laboratory where we can study the life cycles of stars, the dynamics of galactic structures, and the interactions between different celestial bodies. The core of the Milky Way, with its dense concentration of stars and a supermassive black hole at its center, offers a unique opportunity to study extreme gravitational environments and the behavior of matter under intense conditions. The Milky Way is a dynamic and complex system. Its spiral arms are regions of active star formation where gas and dust coalesce to form new stars. These spiral arms are not static. They rotate around the galactic center, driven by the gravitational forces of the galaxy's mass. The structure of the Milky Way, with its bulge, disk, and halo, reveals the intricate interplay of forces that shape galaxies. By mapping these structures, astronomers can infer the distribution of dark matter, which makes up a significant portion of the galaxy's mass, but is invisible to direct observation. New stars are constantly being born, in regions known as nebulae. These stellar nurseries are clouds of gas and dust where gravitational forces cause the material to collapse and form new stars. The process of star formation is a complex interplay of physics, involving the cooling of gas, the formation of protostars, and the ignition of nuclear fusion. Observing these regions helps scientists understand the initial conditions that lead to star formation and the subsequent evolution of stars. While old stars die in spectacular supernova explosions, these cataclysmic events occur when a star exhausts its nuclear fuel and undergoes a dramatic collapse, resulting in a powerful explosion that can outshine an entire galaxy. Supernovae play a crucial role in the universe by dispersing heavy elements into space, which are then incorporated into new stars and planets. The remnants of supernovae, such as neutron stars and black holes, provide valuable insights into the end stages of stellar evolution and the extreme conditions that exist in the universe. By studying these processes, we learn about the life cycle of stars, from their birth in nebulae to their eventual demise in supernovae. This knowledge helps us understand the origins of the elements that make up our world, as stars are the factories where elements heavier than hydrogen and helium are forged. The life cycle of stars is a continuous process that drives the evolution of galaxies and the chemical enrichment of the universe, and the origins of the elements that make up our world. Elements such as carbon, oxygen, and iron are produced in the cores of stars and distributed throughout the galaxy by supernova explosions. These elements are essential for the formation of planets and life as we know it. By studying the distribution of elements in the Milky Way, astronomers can trace the history of star formation and the chemical evolution of our galaxy. The Milky Way is a constant source of wonder and inspiration. Its vastness and beauty have captivated human imagination for centuries, inspiring myths, art, and scientific inquiry. Observing the Milky Way from a dark location away from the light pollution of cities reveals the intricate details of its structure and the sheer number of stars it contains. This experience reminds us of our place in the universe and the endless possibilities for discovery. It reminds us of the vastness of the universe and the mysteries it holds. The Milky Way is just one of billions of galaxies in the observable universe, each with its own unique characteristics and history. As we continue to explore and study the Milky Way, we uncover new insights into the nature of the cosmos and our place within it. The journey of discovery is ongoing, and the Milky Way remains a central focus of our quest to unlock the secrets of the universe.